Hello, everyone, and welcome to today's virtual program from the Commonwealth Club of California. I'm John Zipperer, the club's Vice President of Media and Editorial, and your moderator for this program. We would like to thank our members, donors, and supporters for making this and all of our programs possible. We are, of course, grateful for their support, and we welcome others joining them and supporting the club during these uncertain times. Today, I'm pleased to be joined by Brian Christian, programmer and author of the new book, The Alignment Problem, Machine Learning and Human Values, which was released just last week. He is best known for his theoretical contributions to the tech industry, documented in his best-selling books, The Most Human Human and Algorithms to Live By. In his new book, Christian is posing questions such as, if we continue to rely on artificial intelligence systems to solve our problems, what happens when AI itself becomes the problem? With degrees in philosophy, computer science, and poetry, Christian has spent his career tackling the ethical and technological implications of an advancing society that becomes more reliant on technology. His work has caught the attention of technology leaders such as Elon Musk, who once said Christian's 2011 book, The Most Human Human, was his night table reading. In his new book, The Alignment Problem, Christian lays out our dependence on AI systems, but questions whether or not those systems truly help us. Are these systems simply a replication of inevitable human bias? And how can we get a handle on this technology before we lose control? He argues that although we've trained these systems to make decisions for us, eventually humans will need humans. We'll be discussing a lot in the next hour, and I want to ask your questions too. If you're watching live with us, please put your questions in the text chat on YouTube so that I can work them into our conversation today. So thank you, Brian. Welcome. Thank you for joining us.
It's my pleasure. Thank you for having me.
Great. Now, this is not your first book, of course. I want to ask kind of the opening question that is the obvious question you ask an author, but it really does a good job, I think, of setting the plate for our meal or our conversation here. And that is, why did you decide to tackle this topic now with this book?
Great question. So the initial seed for this book came after my first book had come out. And as you had mentioned, Vanity Fair reported that Elon Musk was his bedside reading. And I found myself in 2014 attending a Silicon Valley book group that was a bunch of investors and entrepreneurs. And they had seen this thing about Elon Musk reading the book, and they invited him to join. And to my surprise, he came. And there was this really fascinating moment at the end of the dinner when the organizers thanked me and everyone was getting up to go home for the night. And Elon Musk forced everyone to sit back down. And he said, no, but seriously, what are we going to do about AI? I'm not letting anyone leave this room until you either give me a convincing counter argument why we shouldn't be worried about this, or you give me an idea for something we can do about it. And it was quite a memorable vignette. And I found myself, drawing a blank. I didn't have a convincing argument why we shouldn't be worried. I was aware of the conversation around the risks of AI. For some people, it's like a human extinction level risk. Other people are focused more on the present day, ethical problems. I didn't have a reason why we shouldn't be worried about it, but I didn't have a concrete suggestion for what to do. And that was the general consensus in the room at that time. So his question of, so seriously, what's the plan? Kind of haunted me while I was finishing my previous book. And I really began to see, starting in, I would say, around 2016, a dramatic movement within the field to actually put some kind of plan together, both on the ethical questions and the sort of further into the future safety questions. And both of those movements have grown, I would say, explosively between 2016 and now. And these questions of ethics and safety, and what in the book I describe as the alignment problem, how do we make sure that the objective that this system is carrying out is in fact what we're intending for it to do? These things have gone from kind of marginal and somewhat philosophical questions at the margins of AI to really today making up, I would say, the central questions of the field. And so I wanted to tell the story of that movement and figure out where, in a way answering Elon's question. What's the plan? What are we doing?
One of the interesting things I thought as I was getting into this was there's a lot of obviously very complex technology and programming that goes into this, but I don't think a lot of people are aware that this is already being applied in some even life and death situations in our society today. We were talking before we started the program that you present a number of examples of failures of AI tools to accomplish what they hope to perform. But one of your examples could not be more timely, and that is the algorithms that are being used by judges, not just here in California, but specifically for what I'm getting into in California, where instead of cash bail, a judge will use this algorithm to determine whether or not a suspect is released or remains in jail while awaiting trial. And this fall, Californians are voting on a ballot proposition, Proposition 25, that would reaffirm a law that would do away with cash bail and would replace it with this algorithm-based system. And it's a very complicated issue, but when and what really surprised me when I was looking at it was, oh, the NAACP and Human Rights Watch oppose this proposition because of what they're saying are some built-in inequities of the algorithm. So why don't we get into that example and kind of build from there? What happened with what's the problem with that algorithm, and how did we get there?
Absolutely. So there is a nearly 100-year-long history of statistical, what were in the 1920s called actuarial methods in parole. This attempt to create a kind of science of probation and parole. And that, as I say, started in the 20s and 30s, but really took off with the rise of personal computers in the 80s and 90s. And today it's implemented in almost every jurisdiction in the US, municipal, county, state, federal. And there has been an increasing scrutiny that's come along with that. And it's been very interesting watching the public discourse kind of pivot on some of these tools. So, for example, the New York Times editorial board was writing up through about 2015 these letters, open letters saying, it's time for New York State to join the 21st century. We need something that's objective, that is evidence-based. We can't just be relying on the whims of, folks in robes behind the bench. We need to bring some kind of actual science to this. Sharply, that position changes, and by just months later, the end of 2015, beginning of 2016, the New York Times is running a series of articles saying algorithms are putting people in jail. Algorithms have seeming racial bias. We need to really throw the brakes, and calling out by name this particular tool, which is called COMPAS, which is one of the most widely used tools throughout the United States. And the question this really has ignited an entire subfield within statistics around this question of what does it mean to say that a tool is fair? This system is designed to make predictions about whether someone will reoffend if they're released, on probation, or if they're pending trial, for pretrial. What does it mean to take these concepts that exist in the law, things like disparate treatment or equal opportunity, et cetera, 14th Amendment protections, et cetera? What does it mean to actually turn them into the language of code? And how do we look at a tool like this and say whether we feel comfortable actually deploying this?
And I mean, it was interesting when you're actually giving some examples of how a black suspect and a white suspect with similar crimes, similar backgrounds, and how much more likely the white suspect was to go free, including surprising at one point one of the white suspects who was interviewed. He was like, I don't know what to get, let me go. So what goes into, if you will, the baking of that cake that built these biases in here? Because the biases were not intentionally baked into it, but they're still hard baked in there in some way.
Yeah. So this is a very big conversation. I think one place to start is to look at the data that goes into these systems. So one of the things that these systems are trying to do is predict one of three things. Let's just think about the pretrial case for now. Typically, a tool like Compass is predicting three different things. One is your likelihood to not reappear, not make your court appointment. The second is to commit a nonviolent crime while you're pending trial. And the third is to commit a violent crime pending trial. The question is, where does the data come from on which these models are trained? And if you look at something like failure to appear in court, well, if you fail to appear in court, the court knows about it by definition, right? So that's going to be fairly unbiased in that sense, regardless of who you are. If you don't show up, the court knows about it. If you look at something like nonviolent crime, it's the case that, for example, if you poll young white men and young black men in Manhattan about their rate of self-reported marijuana usage, they self-report that they use marijuana at the same rate. And yet, if you look at the arrest data, the black person is 15 times more likely to be arrested for using marijuana than the white person is in Manhattan. In other jurisdictions, it might be 8 times as likely, I think, in Iowa. And, it varies from place to place. So that's a case where it's really important to remember that the model claims to be able to predict crime, but what it's actually predicting is rearrest. And so rearrest is kind of this imperfect and systematically so proxy for what we really care about, which is crime. It's ironic to me because as part of this project of researching these systems, I went back into the historical literature when they first started getting used, which was in Illinois in the 1930s. At the time, a lot of the objections were coming from the conservatives, from the political right. Ironically, making almost the same argument that progressives are making now, but from the other side. So conservatives in the late 30s were saying, now, wait a minute. If a bad guy is able to evade arrest, then the system doesn't know that he committed the crime, and the system treats him like he's innocent and will recommend his release and recommend the release of other people like him. Now we hear it being made from the left, which is to say, if someone is wrongfully arrested and wrongfully convicted, they go into the training data as a bad person, as a criminal, and it will recommend the detention of other people like them. This is really the same argument, just framed in different ways. But that's a very real problem, and we're starting to see groups like, for example, the Partnership on AI, which is kind of a nonprofit industry coalition of Facebook, Google, and a number of groups. In fact, almost 100 different stakeholders, recommending that we don't take these predictions of nonviolent rearrest as seriously as we take, for example, the prediction of failure to reappear. And the second component that I want to highlight here, I mean, it's a very vast question, but the second thing that's worth highlighting is this question of what do you do with the prediction once you have the prediction? So let's say you've got a higher than average chance that you're going to fail to make your scheduled court appointment. Well, that's a prediction. There's a separate question, which is what do we do with that information? Now, one thing that you could do with that information is put the person in jail while they wait for their trial. Now, that's one answer. It turns out there's an emerging body of research that shows things like if you send them a text message reminder, they're much more likely to show up for their court appointment. And there are people proposing solutions like providing daycare services for their kids or providing them with subsidized transportation to the court if that's an issue for them. So there's this whole separate question, which is as much is going on, as much scrutiny is rightfully being directed at the actual algorithmic prediction. there's a much more systemic question, which is what do we do with those predictions? Um, and if you're a judge and the prediction says that this person is going to fail to reappear, well, ideally, you'd want to recommend some kind of text message alert for them as opposed to jail. But that may or may not be available to you in that jurisdiction. And so, you have to kind of work with what you have. And that's a systemic problem. That's not necessarily an algorithm per se, but the algorithm is sort of caught in the middle, if you will.
Let's take it out of the crime and punishment era into the business area. And you talk later in the book about hiring. And I believe it was Amazon, coming up with this AI system that would help it cull job applicants. And what they were finding was that they were ending up, of course, with a lot of men. And the reasons for this also were baked into the way the system was being trained and the way the system was being used. And then I think also when we get to this, you still also have the questions at the end of like, well, why were you trying to find people who were just like the people you had? But still, right. Tell us about that and what were they? How did they get in? Step in, if you will.
So this is a story that involves Amazon around the year 2017. But by no means are they the unique example here. It just happens to be the example of Amazon. But they, like many companies, were trying to design systems that could take a little bit of the workload off of human recruiters. And if you have an open position, you start getting X number of resumes coming in. Ideally, you'd like some kind of algorithmic system to do some triage and tell you, okay, these are the resumes that are worth forwarding on or looking at more closely. These we think are, lower priority. And in a somewhat cute or ironic twist, Amazon decided they wanted to rate applicants on a scale of 1 to 5 stars. So rating their prospective employees the same way that Amazon customers rate Amazon products. But to do that, they were using a type of computational language model called word embeddings or word vectors. And without getting too technical, for people who are familiar with kind of the rise of neural networks, these neural network models that were very successful at computer vision around 2012 also started to move into computational linguistics around 2013. And in particular, there was this very remarkable family of models that were able to sort of imagine words as these points in space. And so if you had a document, you could predict a missing word based on the other words that were nearby in this kind of abstract 300-dimensional space, if you can imagine that. But these models had a bunch of really cool other properties. So you could actually do kind of arithmetic with words. So you could do king minus man plus woman, and search for the point in space that was nearest to that, and you would get queen. You could do Tokyo minus Japan plus England and get London, and these sorts of things. And so these numerical representations of words that fell out of this neural network ended up being useful for this surprisingly vast array of tasks. And one of these was trying to figure out the quote unquote relevance of a given CV to a given job. And so one way you could do it is just say, here are all the resumes of the people that we hired over the years. Throw those into this word model and find all those points in space. And then for any new resume, let's just see which of the words in that CV have the kind of positive attributes and which have the negative attributes. Okay, well, it sounds good enough. But when the team at Amazon started looking at this, they found all sorts of bias. So, for example, the word women's was assigned a penalty. So if you played, you went to a women's college or you're on the women's society of something, the word women's on that CV was getting a negative deduction.
It's getting a negative rating or whatever because it's located farther away from the more successful words that it's been trained to watch for. Is that right?
That's right. It doesn't appear on the typical resume that did get selected in the past, and it's similar to other words that also didn't sort of appear in those resumes. So of course the team, the red flag goes off, and they say, okay, we can delete this attribute from our model. They start noticing that it's also applying deductions to like women's sports, like field hockey, for example. So they get rid of that, or women's colleges, like Smith College, so they get rid of that. And then they start noticing that it's picking up on all of these like very subtle syntactical choices that were more typical of male engineering resumes than female. So, for example, the use of words like executed and captured, like I executed a strategy to capture market value or whatever, certain phrases that just were more typical of men. And at that point, they basically gave up. They scrapped the project entirely. And in the book, I compare it to something that happened with the Boston Symphony Orchestra in the 1950s, where they were trying to make the orchestra, which had been very male dominated, a little bit more equitable. So they decided to hold the auditions behind a wooden screen. But what someone found out only later was that as the auditioner walked out onto the wooden parquet floor, of course, they could identify whether it was a flat-soled shoe or a high-heeled shoe. So it was not until, I think, the 70s when they additionally instructed the people to remove their shoes before entering the room that finally you started to see the gender balance in symphony orchestras start to balance out. And the problem with these language models is they basically always hear the shoes, right? They're detecting the word executed, they're detecting the word captured. And the team in this case just gave up and said, we don't feel comfortable using this technology. Whatever it's going to do is going to identify some very subtle pattern in the engineering resumes we've had before. The gender balance was off there. So it's just going to sort of replicate that into the future, which is not what we want. So in this particular case, they just walked away. But this is a very active area of research of how do you debias a language model. You've got all these points in space. Can you try to identify subspaces within this giant 300-dimensional thing that represent gender stereotypes? Can you delete those dimensions while preserving the rest? This is an active area, and it's kind of ongoing to this day.
How much did Amazon spend developing that?
It's a great question. They're pretty tight-lipped about it. Most of what we know comes from a Reuters article where people weren't giving their names. So I wasn't able to do a lot of follow-up. But as I understand, they actually not only disbanded the product, but they disbanded the team that made it and redistributed the engineers to other things. So it was really washed their hands.
Yeah, I'm asking because however many, I assume millions were put into that. They could have hired an extra HR person or two to cull their stuff.
Yeah, that's right.
Well, another example I wanted to get into, and it might be coming at it from a different angle, is the self-driving car. And you talk in the book about, the fatality that happened because of the way the car was recognizing this person.
That's right.
Again, explain that and what was the problem there?
Yeah, so this was the death of Elaine Hertzberg in Tempe, Arizona in 2018. The first pedestrian killed by a self-driving car was the sort of R&D Uber vehicle. And the full kind of National Highway Transportation Safety Board review came out at the end of last year. So fortunately, I was able to get some of that into the book before it went to press. And it was very, very illuminating to read the kind of official breakdown of everything that went wrong, because it was one of these things where probably 6 or 7 separate things went wrong. And you think if it had only been, but for that entire suite of things going wrong, it might have ended differently. One of the things that was happening was it was using a sort of deep neural network to do object detection. But it had never been given an example of a jaywalker. So in all of the training data that this model had been trained on, people walking across the street were perfectly correlated with, zebra stripes. and they were perfectly correlated with intersections and so forth. And so the model just didn't really know what it was seeing when it saw this woman crossing the street in the middle of the street. And most object recognition systems are taught to classify things into exactly one of a discrete number of categories. So they don't know how to classify stuff that seems to belong to more than one category. They don't know how to classify stuff that seems like it's not in any category. So this is again one of these active research problems that the field is making headway on, only recently. But in this particular case, the woman was walking a bicycle, and so this set the object recognition system kind of into this fluttering state where it first thought she was a cyclist, but she wasn't moving like a cyclist. Then it thought she was a pedestrian, but it was recognizing the shapes of a bicycle. Then it thought maybe it's just some object that's been sort of blowing or rolling into the road. No, I think it is a person. No, I think it is a biker. And due to a quirk in the way that the system was built, every time it changed its mind about what type of entity it was seeing, it would reset the motion prediction. So it's constantly predicting, this is how a typical pedestrian would move, this is how a cyclist would move, et cetera. And extrapolating, okay, this is as a result where I think they're going to be in a couple seconds from now. And if that intersects the car, then it's going to do something. But every time it changed its mind, it started recomputing that prediction. And so it never stabilized on a prediction. So there were additional things here with overrides that the Uber team had made to the normal, because in 2018, most cars already have this very rudimentary form of self-driving. Well, they're going to automatically brake or, in some cases swerve. They had to override that to sort of add their own system in, and those two systems interacted in weird ways. But I think the object recognition thing itself is, for me, very thematic. And there's this question of certainty and confidence, that when a neural network says, I'm 99% sure this is a person or whatever it might be, how do we know if those probabilities are well calibrated? How does the system know what to do with them? I think many people kind of within the deep learning uncertainty community now would argue that the mere fact that you are changing your mind should be a huge red flag. You need to slow the car down. That alone. And that wasn't done. So yeah, I mean, it's very heartbreaking to think about how all of these engineering decisions add up to this event that would have been so much better to have avoided. I guess the silver lining is that there are lessons in there that are really being taken to heart, not just in industry, but also in academia, saying, okay, we really need to get to the bottom of this question of certainty, uncertainty, because I think that's a very human thing. You don't want, I mean, this exists in the medical literature. You don't want to take an irreversible action in the face of uncertainty. You don't want to take a high impact action. You see it also in the law, in things like what's the term? Like a preemptive judgment. I'm forgetting the term, but a judge might issue an order in advance of deciding what the real thing would be because they're trying to prevent some irreparable harm. And so there's a question for the machine learning community, which is, how do we take some of these same ideas, not wanting to make an irreversible choice in the face of uncertainty or in the face of a very high impact situation? That requires us to quantify impact and quantify uncertainty and have a plan for what to do when we find ourselves there. So all those pieces need to come together, but we're seeing progress being made on all of those fronts. And it can't happen soon enough.
In these examples that we've talked about, and in others that are in the book and others that you didn't include in the book, but that you see, are the culprits the same? Is it the same general problem that you think needs to be addressed? And then I'm going to ask, of course, do you think it is being addressed to your satisfaction?
I think there's one broad problem, which in the field is known as the alignment problem, and that's where the book gets its title, which is just how do we make sure that the objective in the system is exactly that which we want the system to do. And I think all of the examples that we've highlighted so far have shown us cases where one must be very careful to think about how to translate the human intention into an actual machine objective, right? We think we think we can measure reoffense, but we can't. We can only measure rearrest. We think we can hire promising candidates. We can only hire candidates that superficially resemble previous candidates. We think we can classify objects into different categories, but many objects belong in more than one category, or we don't always know what category to put them in, and we have to act knowing that we don't know. So all of these things, and there are many other manifestations as well, I think speak to this fundamental issue of alignment, but the actual mechanics are different. Sometimes there's a problem with the training data. Sometimes there's a problem with the model architecture. So one problem that we haven't touched on yet is this kind of black box issue of interpretability, explainability. How do we know what's going on inside a model? How can we trust the output and reverse engineer what about the input generated that output? There are questions of what is the so-called objective function of the system? What is the quantity we're trying to minimize or maximize, and how do we define that? So each component of the system has its own, manifestation of the alignment problem. And each of them, to your second question, is it being addressed? Yes. And that for me is really the striking thing that makes where we are now so different from, where we were when Elon Musk cornered me and a bunch of executives in a room and no one had any, particularly good ideas. I think we're seeing a absolutely remarkable shift in the field that even just from, I talked to one researcher, a PhD student, who said when he went to the biggest industry conference in 2016, and he said he worked on AI safety, people kind of raised their eyebrows at him, like he was a little bit kooky or he was a little bit paranoid or something. He came back a year later in 2017, and there's like an entire day-long workshop on AI safety. And by 2018, it's a significant fraction of the papers being presented at the conference. And so in absolute numbers, the amount of people working on this is still quite small, but the growth, even over that short time, has been, to my mind, astonishing. And, I think we can't, it can't come soon enough. So I encourage all motivated, undergrads and high school students to get excited about this area, because I think there's a lot of work to be
done. In talking about, there's obviously a lot then of learning and development that's going on the AI in the AI research and development field. Is the actual commercialization of this technology then ahead of where it should be? I mean, and should this all still be where this is all still being modeled and not put on our roads, put in our courtrooms?
That's a great question. Yeah, in some ways, I mean, with the criminal justice stuff, as I say, it's got a 85-year history at this point, but it's as if we're still playing catch up in terms of the analysis relative to the deployment. So you can think of it sort of as a kind of race. Can the understanding catch up to the actual implementation? And I think we've seen that with social media. There were some decisions that Facebook made about how to run their newsfeed ranking algorithm, and the details are somewhat technical. They went from supervised learning to reinforcement learning. We don't have to unpack that exactly, but basically the narrow-minded focus on always prioritize the content that will get the most clicks on that thing created a situation where extreme content was being promoted, people were burning out, people were leaving the platform, in addition to the many other kind of societal externalities that was creating. And they were able to replace it with a more advanced model that factored in that you could burn someone out, or that they would start to distrust the platform, et cetera. And, cynically, you could note that part of the point of that model was to maintain user retention and these things that were good for their bottom line. I think there really is a question of uh, when you think about the alignment problem, is the system doing what we want? I think when you look at actual industry, there's the meta question, which is, what is it that we want the system to be doing? And who's we in that sentence as well? And I think those questions are going to loom ever larger.
Well, and we have seen in general media kind of more urgency put, over the past few years, that when this topic does come up in one way or another, there's more urgency behind the people who are saying, we need to be thinking about this. We need to be thinking about implications. And because, as we said, this is already being rolled out, one of our audience members asks about China's widespread use of facial recognition and possible, Orwellian sort of 1984 implications. In the book, of course, you do talk about facial recognition technology and the inappropriately funny result of it, which was just absurd, but also insulting. And obviously in today, it has even worse implications. But could you talk a bit about facial recognition? Because this is another thing that, in fact, here in California, it became, I think, a proposition, at least locally it has been, about whether or not to use these technologies. So tell us a bit about that and how it fits into this, what you're talking about here.
Yeah, I mean, so this is coming through the legal system now. If I'm remembering correctly, I think the first case in, I want to say Minnesota or Wisconsin, of someone being arrested by being incorrectly identified in a facial recognition database. So a lot of this stuff is going through the court system and probably headed for the Supreme Court. On the technical side, yeah, there is this really unfortunate and kind of hard to ignore pattern, in particular of ethnic minorities being incorrectly recognized or categorized, et cetera, by face recognition systems. One of the famous examples was the software developer Jackie Alcine in 2015. A group of photographs that he had taken of himself and a friend was captioned by Google Photos as gorillas. And another example is the MIT researcher Joy Buolamwini, when she was an undergraduate computer scientist doing these facial recognition homework assignments. She had to borrow her roommate in order to check and make sure that the face system worked, because it didn't work on her, or it worked on her only when she wore a white mask. And this really set off an investigation of why does this keep happening? What's the underlying thing? And there are a couple different components to it, but I think one of the main ones is there had been, I think, a pre-existing lackadaisical attitude to how these databases of faces were put together in the first place. So, part of what led to the rise of computer recognition was the internet. And suddenly, if you needed 500,000 examples of a human face in order to train your system, well, in the 80s, you were totally out of luck. But now that we have the internet and Google Images and all these things, you can just download 1 million faces and put it into your system. The question is, which faces are you downloading? So the most popular research database for many years was one developed in the late aughts called Labeled Faces in the Wild. And they thought, okay, what we want to do is understand whether two faces are in fact the same person. So we have this clever idea. We'll scrape newspaper headlines or newspaper images, because they're all labeled with this person and this person and this person. And that way we'll have this giant data set and we can decide, are these two images the same person, et cetera. The problem is that you're at the mercy of who was in, front page news photographs in the late 2000s. And the answer is George W. Bush, then President George W. Bush. And in fact, an analysis of the Labeled Faces in the Wild data set that was done just a few years ago showed that there were twice as many pictures of George W. Bush in the database as all Black women combined, which is just insane. I mean, if you're trying to build something, now, to be fair to the people who collected that data, this was a kind of an academic research project. This was not intended to be used in any actual system, but these data sets have a way of kind of sticking around, and someone just downloads it off the internet, or it's the most cited thing. So if you want your paper to be cited, you have to use the same thing they used. And it's very striking if you look at the original papers, and I don't want to single them out because it was widespread. The word diversity is getting used in the sort of late aughts, early 2010s to mean lighting and pose. So they'll say, this is the most diverse data set assembled to date. But what they mean is we have people from the side, we have people in the dark, we have people who are lit weirdly. Now at the end of the 2010s, the beginning of the 2020s, it's very striking because some of these old canonical databases now appear with a warning label on it that says, when we said diversity, we meant a very specific thing, and we want to flag that it's very much not diverse in the sort of demographic sense. So there's a lot of work that's being done there, spearheaded by people like Joy Buolamwini at MIT and Timnit Gebru at Google Brain, to bring a lot more focus on equalizing the error rates across different ethnic groups, making sure that the database, the training data actually represents the population that the model is going to be used on, and thinking also about the representation of tech itself. And so I think in 2019, only less than 1% of computer science PhDs were African American. And so there's a lot of work to be done in the field itself to address that question of representation. And so we're seeing groups like Black in AI, which has a number of initiatives, including scholarships and grants and things like that, trying to equalize that, not, as I say, not just in the training data, but indeed in the field itself.
There's a question from the audience about, kind of some of what we're talking about, male-dominated answers that are being baked into the design. In the book, while you're discussing debiasing word embeddings, removing gender interpretations of words to allow gender-neutral evaluation, as we mentioned earlier, you mentioned a work that a group of researchers did. I'm going to mispronounce his name, Tolga
Bulukbasi. Yeah.
Bulukbasi and Adam Kalai.
Yeah.
And they're collaborators. And you noted that, quote, the team of 5 computer scientists found themselves doing, in effect, social science, unquote. That would seem to be a requirement for any of this work because of all the different interpretations one has to take in, and understanding the fuzziness of the social science that has to somehow be mixed in with the hardness of the computer science, right?
I think that's absolutely right. And that, to me, is one of the really striking things about where the field finds itself at this moment, which is that I think no longer can, data scientists and software engineers think of themselves as purely doing engineering or purely doing mathematics. That we've just gotten to a point where these systems are absolutely enmeshed in kind of human practices of how is the data collected, how is the data generated, how is the question that the human respondents were being asked, how is it worded? Because you're going to get different answers based on how it was worded, and what population of people were you sampling it from? So, are people on Amazon Mechanical Turk representative or not representative of other groups that might, respond to the same thing? So we're very much in this moment of, to my mind, kind of exhilaratingly interdisciplinary work that needs to happen and is happening between the computer science, machine learning community and, social scientists, philosophers, ethicists, lawyers, cognitive scientists. There's a lot of really interesting work being done at the intersection of AI and infant cognition. We're now sort of at the point where AI essentially resembles an infant. And so the machine learning community is going to developmental psychologists and saying, what's your best theory for, the curiosity of an infant, or the sort of novelty bias that small kids have, or the exploratory play that kids will have with a particular toy to figure out how it works. And because we need to import that into our AI system to solve this problem. And in turn, the AI system might be unlocking some of these questions of why do infants have these sorts of drives? So there are many, many fronts on which this is happening. The social sciences, I think, are kind of uniquely positioned at that interface with computer science. And we're seeing many more papers with a really diverse set of skills among the authors. And I think that's the kind of thing, to me, that's very encouraging.
Well, as we mentioned at the beginning, you have an interesting skill set yourself, an author, poet, and programmer. I suspect the Venn diagram of poets and programmers is two barely touching circles. But does that set of skills help you maybe see out of some blinders that might otherwise have been there with you, do you think?
Yeah, I mean, I could joke that, poetry and programming have in common, excessive scrutiny over semicolons. But beyond that, yeah, I mean, my background also with philosophy was that um, when I was a student, I was really interested in this question of what is thinking, what does it mean to have a mind, to be conscious, etc. And philosophy of mind sort of takes one angle on that question, and AI answers it in a different way by sort of trying to actually make it. And so I think, yeah, broadly speaking, it's been a question for 2,500 years of Western philosophy. What does it mean to be human? What makes us unique and special and distinct? And Aristotle to Descartes and so forth have answered that question by comparing ourselves to animals. And I think there's never been a more interesting time to be thinking about this area, because we now have a completely new standard of comparison, the computer, and you get a totally different set of answers. So Aristotle and Descartes end up deciding that, analytical, deliberate reasoning is the core of what it means to be human, because that's what, dogs and monkeys can't do. I don't think anyone who's thought seriously about AI thinks that deductive analytical reasoning is like the seat of the human experience. You get a different kind of answer that's more about empathy, imagination, social ties, teamwork, collaboration, etc. So yeah, for me, I mean, I think in some ways I feel very lucky that I had this very eclectic set of interests and happened to be alive at the time in human history where these two disciplines are on an absolute collision course.
Someone in our audience asks, do you believe that human-like machine sentience will ever be achieved? In other words, Kurzweil's singularity.
Well, there are a number of things that people mean by the word singularity. So there's some people for whom it means something that is also called the hard takeoff, where there's kind of an abrupt moment in time where AI starts like recursively self-improving and just blindsides us. Um, I don't really see that. I'm in the camp of what is sometimes called the slow takeoff, where I think AI is just going to be getting weirder and spookier and more uncanny until we just accept that it does everything we would, require a thinking or intelligent thing to do. But that there won't be a sort of sharp elbow turn where this like suddenly happens overnight. From my perspective, though, it's totally inevitable. I mean, there's a long history within computer science going back to, the 1940s. Claude Shannon was asked, "Do you ever think a machine can think?" And he said, "Of course, I'm a machine and I can think." And if you have a kind of secular worldview, you're not a non-dualist, then you think, well, the brain's made of atoms, computers are made of atoms. It's all about the sort of emergent behavior of a certain level of complexity. And I think thrillingly and sort of spookily, we're on that roadmap. So OpenAI just released a language system called GPT-3 a few months ago that has 175 billion parameters. Well, if you compare that to the number of synapses in the human brain, it's about 1/1000th of the complexity of a human brain. Doesn't sound very impressive, 0.1%, but the average model size within that field of AI is doubling every 3 months. So if you do the math, that means that we should expect models to exist that have the synaptic complexity of a human brain sometime in like the spring of 2023. That's not very far away. So sooner or later, I think these questions that still feel a little bit sci-fi are going to really start to come to the surface. I don't know what the answers will be, but I mean, this is, I think, one of the really riveting things about this moment.
Yeah, there was a story recently about these two computers that I forget the details on it, but they had to communicate with each other, and they apparently spontaneously developed their own language for communicating with each other because it was faster than using whatever else they had available. And in talking about just the need that we have for AI to develop in certain ways, to align with what we want it to do and what our needs are. Thinking about those robots kind of solving a problem in a completely different way. Is it possible that we will get artificial intelligence that is much more advanced and that is able to deliver us results that are more understandable, more in alignment with what we want to see, but that their way of reaching it will be totally alien?
That's a great question. I think both of those possibilities are live possibilities. I think one of the things that is sometimes forgotten when we talk about AI, there's a certain lens of inevitability that we can cast onto this question of progress and so forth. But there are real choices to be made about the architecture of these systems. Um, for example, I mean, it's already the case with self driving cars, for example, that you can do what's called training the system end to end. You can just have a giant blob of neural network and you put the camera feed in the bottom and the steering wheel commands come out the top and you have no idea what's going on in the middle and you just hope it's fine. There's an increasing science to the question of kind of how do you pop the hood and figure out what is going on in the network, but also how do you constrain the network in certain ways. For example, can you constrain it to be modular, so that the system is naturally divides into these subcomponents that you can then analyze individually and say, okay, I know what this thing is doing, so let me now worry about what's going on over here. Um, there's a lot of really encouraging results in that space. And so I think to your question, uh, will AI be able to do what we want, but in a way that's totally inscrutable? Yes, but that's not necessarily the only way that it can happen. And so I think we will have some more agency there than I think is sometimes appreciated to build the kinds of systems that we feel we can trust.
When you talk about artificial intelligence, how often do people just ask you about Terminator and Skynet?
You know, it's funny. It's been very interesting to watch the canonical questions that I get, evolve. And when my first book came out in 2011, 2012, a lot of people were asking me, is AI coming for my job? By 2014, 2015, people were asking me, is AI going to destroy all of humanity as we know it? So the stakes had really gone up there. Um, and within the research community, the cautionary tale has kind of shifted from um, one that feels more like, yeah, sort of a disobedient system to one that feels more like a system. I use the analogy in the book of like the sorcerer's apprentice. It's trying to be helpful, but it doesn't quite know what you wanted it to do. There's a famous thought experiment that comes from Eliezer Yudkowsky at Machine Intelligence Research Institute of what's called the paperclip maximizer. So, it's this fictional thought experiment of imagine you're a paperclip factory, you buy this AI and you say, we really want to increase the output of our paperclips. Unfortunately, this thing is so good that it basically turns the entire universe into paperclips, including yourself and your loved ones and so forth. So, that's a little bit caricatured, obviously, but that is, I think, the kind of thing that people work on alignment are worried about. It's not a system going rogue. It's not a system deciding that humans need to be exterminated. It's a system in a sort of poignant way trying to do what it thinks we wanted it to do, but realizing, we realized perhaps all too late that we weren't quite specific enough. I mean, again, it's the Sorcerer's Apprentice or King Midas or one of these things. And so, part of what the alignment problem, part of what solving that alignment problem would mean is feeling comfortable communicating an intention to a system like that without necessarily needing to get every specific detail right, before we press the button. We're having a system that's kind of flexible. The scientific term is corrigible, but it can sort of adapt on the fly. It can take feedback. We can say, "Hold on, that's not what I meant," and that is the kind of thing that I think makes myself and a lot of people who work on this area a little bit more relaxed than we were 3-4 years ago.
One of our audience members notes that he's a former computer engineer 30 to 60 years ago. He says software people all wanted to be systems analysts, not programmers. And he asked kind of what do they want to be called today. I want to ask, actually kind of turn that a bit and ask, because we were talking about how the field now is becoming much more interdisciplinary, is looking to learnings and input from other fields. Are the people who are in the AI field changing? Are there people from other fields who are like, I want to go into that field? Or, are the people with earlier majors switching over into this different from maybe they were 10 years ago?
That's an interesting question. To the question, like to the initial point about, being a systems analyst, I was thinking about the head of AI at Tesla, Andre Karpathy, has this notion of what he calls software 2.0. That software 1.0 was programming, line 1, if X, then line 2, do Y, it's, else, blah. Software 2.0 is the world that we're in now with machine learning, where you don't write code, you provide a set of training examples and say, do something like that. There's sort of a debate over whether there's going to be a software 3.0, which is this fully general AI system that you just have to sort of make requests. You don't give it explicit training data, but you kind of work with it after the fact. And GPT-3 is sort of in that category. And working with GPT-3 feels a lot more like this kind of soft science thing, where you're writing almost like an essay prompt. So GPT-3 is a language model that's designed to essentially just fill in the blank in a piece of text. You can use it to do all sorts of things. You can say, the following is a Python program to sort a list of integers, blank, and it will write Python code for you. You can say, the following is an argument that rebuts the most common objections against X, and then it will give you some, little essay. And what it means to sort of use a model like that starts to feel a lot more like how to work with another person. How do you word something so that the meaning comes through, or you get the tone that you want, or the style that you want, et cetera, et cetera. So there is, I think, going to be this new category of people who are not exactly programmers, not exactly machine learning people or statistics people, but people who are sort of wrangling these giant models through natural language. And that's kind of a new job that doesn't really exist yet. And that's going to require, I think, a very interesting set of skills. It's going to require, a certain linguistic felicity, because the words that you use are very important. It's also going to require an intuition about how these large models are trained, because that'll help you figure out, why it might not be doing something that you want. More broadly, I think as the questions that machine learning is dealing with become more and more human, it does invite a certain kind of person who might not have felt like they belonged to now feel like they do belong, and feel like their skill set can plug into that and their interest can plug into that. And I think that's what we're starting to see. And I think that is a shift that is really just beginning.
Who were you trying to reach with this book? Who are you hoping will read it and really take away from it the message you need them to get? Is it a general audience? Is it the AI community? Is it the companies and entities that are trying to use this technology and adopt it?
That's a great question. I think there are a couple audiences. One is just the general public. I think relative to other fields in science, AI, machine learning, and even these questions of bias, ethics, safety have been sufficiently in the press that a lot of people are aware of them, whether or not they've really taken the time to kind of go deep and understand the underlying issues. And so part of what I want to do is say this debate is already happening. I want to try to raise the level of the debate, give people some of the conceptual insights, some of the basic vocabulary, so that we can feel comfortable talking about this thing that is now affecting all of us. I think it also, there's a huge class of people who went through their career with a particular kind of training that didn't ever seem like it required them to know about machine learning. Maybe you're a judge. Now, suddenly in the year 2020, you're being handed these algorithmic recommendations. What do? You're a lawyer or you're a medical diagnostician. And now you're being given these machine predictions about cancerousness and so forth. There's a lot of people out there that suddenly need some level of familiarity in this area. And so I hope the book can fill a need there as well. And then lastly, I hope it can just grow the field. I genuinely think this is one of the most exciting and most important things that's happening, not just in computer science, but in science, period. And so if I can reach, bright high school students, bright undergrads, and get them excited about this area, get them bugging their advisor, give me a cool project that I can do on safety. What can I do? Let's get started. I think that for me will feel really good if I can grow that field and bring even more folks into the movement. I think that'll be a very good thing.
Well, we've got time for just one more question. So this is the time travel question. In your book, you, of course, talk about some of the earliest steps in developing AI. But now if you were shot ahead 20 years in time, what realistically would you expect to see the state of AI, both in terms of research and direction, as well as in actual deployment in real life?
20 years is interesting. There's the joke in AI that, starting in 1955, AI was always 20 years away, and it still is. But I think, realistically, there will be sort of of course, a generational replacement that happens over that time. And I think the way that we now have people who we think of as kind of digital natives, social media natives, there's going to be a generation of like AI natives that that generation of people that are just being born now, they will grow up in a world where they may not get driver's licenses. It may become illegal, like morally outrageous. How can you justify, a human driving a car? It's so dangerous. And they will, I think, come to understand themselves as inhabiting a world in which there are all these different systems with kind of different degrees of what you might call intelligence, different degrees of what you might call agency, different incentives that align with our own to one degree or not, and interfaces that increasingly look like the way people talk to each other. Kids have no problem talking to Alexa, for example. They find it fairly normal that there's some kind of system that you can just chat with, which is sort of remarkable, even if you think back 10 years. That was totally not something anyone was familiar with. So, yeah, I think in some ways the boundary will start to get blurry between that technical skill set and just the skill set of navigating the world of other humans, because these systems will sort of increasingly start to feel like they kind of speak that same language. You can communicate by gesture. You sort of reach or point to something and your household robot grabs you the item it thinks you're reaching for, but you're like, no, the other one. Or you communicate in words, the way you would communicate with a kind of a personal assistant or something. I think we're going to have this new generation for whom that just is the way the world works. And hopefully we will set them up to have a reasonably good world indeed at that point.
Very good. Well, our thanks to Brian Christian, author of the book, The Alignment Problem, Machine Learning and Human Values, for joining us today. We'd also like to thank our audience for watching and participating online. If you'd like to watch more programs or support the Commonwealth Club's efforts in producing its virtual programming, please visit commonwealthclub.org/online. I'm John Zipper. Thank you. I'm wishing you a good day and hope you stay safe and healthy. Thanks a lot, everybody.
Hi, I'm Dan Ashley, the evening news anchor for ABC 7 News in San Francisco, and I hope you and your loved ones are staying safe, healthy, and comfortable during these very challenging times. I am also a proud board member of the Commonwealth Club, one of our most important Bay Area institutions. The club has been hosting wonderful events with exciting speakers and topics in the Bay Area for over a century. In times of crisis, good information and strong connections in our community are especially important. And during the current COVID-19 crisis, the club has really stepped up. Since March 6th, the club has brought you over 200 live-streamed events with speakers and panelists, including past governors, secretaries of state, university presidents, and noted health experts. Every program includes a live chat, so you and viewers all over the Bay Area and beyond have been able to ask these experts the questions that are on your minds. Every program has been neutral and unbiased in true Commonwealth Club style to get to the bottom of the issues that are so drastically affecting our lives. The club has done all this public service despite being profoundly affected by the crisis. The inability to hold events for the past 2 months has forced the club to cut its budget and staffing by 50%. The remaining staff are working from home to bring the community these valuable and informative live-streamed programs. The club needs your support to continue its shelter-at-home programming. Please make a tax-deductible donation to the club now by texting the word DONATE to 329-4231. That is, donate to 329-4231, or visit the Commonwealth Club website, commonwealthclub.org. We need the club to be here in the months and years ahead to help inform and educate as we figure out how to get our society and our economy safely moving again, consider changes to the way we live, and work as a result of this crisis, and take steps to prevent a future pandemic. Once again, please support the Commonwealth Club now by texting the word DONATE to 329-4231. That is, donate to 329-4231, or visit the website commonwealthclub.org. I want to personally thank you for supporting one of our community's truly great organizations. I'll see you on ABC 7 News and at the Commonwealth Club. Stay safe.